So one such circuit is a Miller Crystal Oscillator. So Miller Crystal Oscillator means I'm going to use the crystal in my part of my circuit. So the crystal has two resonant frequencies. So in between the resonant frequency, the crystal is inductive, right? So I'm going to use this property and I'm going to use this crystal as an inductor, L. I'm going to use this crystal as an inductor by operating the crystal between the two resonant frequencies. So one of the inductor in Hartley oscillator is replaced by crystal. So you know in Hartley oscillator you have L1, L2 parallel to C. L1 is going to be L. L2 is going to be replaced by crystal. And you know this crystal, when you operate the crystal between the series and parallel frequency, it produces inductive effect. So I'm going to replace one inductor in Hartley oscillator by this crystal so that I at least try to make my circuit compact in that way. Okay, so I see here 1L parallel to C I have from the feedback path. The feedback is given to crystal oscillator to the base of the transistor. So this is Miller Crystal Oscillator, and inter-electrode capacitance of transistor acts as a capacitor to generate oscillations in the circuit. So between the terminals of the transistor, you have so much amount of capacitance, right, which are all visible at high frequency. You know this, whenever you use LC oscillators, it is going to be high frequency. So these capacitance will also play a role along with the inductor in determining what is the frequency of oscillation for a Miller crystal oscillator. So you cannot neglect the effect of these capacitances in the frequency of your, in the operation of your